Chapter 5, Section 3, Encoding Categorical Variables. Many real-world datasets contain categorical data. Since machine learning models typically work with numerical data, we need to convert categorical values into numerical representations, a process called categorical encoding. This section will cover the three main encoding techniques: one-hot encoding, label encoding, and ordinal encoding. When to use each method. The advantages and limitations of each technique. By the end of this session, you will understand how to choose the right encoding method based on the characteristics of your data and your analytical goals. Many datasets contain categorical variables, which can be nominal or ordinal. Nominal variables are unordered categories. Ordinal variables are ordered categories. Since machine learning models work with numerical inputs, we need to convert categorical variables into numbers before feeding them into an algorithm. However, different encoding techniques should be used for serve different purposes, and choosing the wrong method can be lead to biased models. Let's start with one-hot encoding. One-hot encoding creates binary 0 or 1 columns for each category. It is used when categories have no meaningful order, that is, nominal variables. As an example, consider an HR dataset with employee department categories. Let's apply one-hot encoding to this dataset. Now, each category is represented by a separate column, where 1 indicates the presence of the category and 0 indicates absence. Columns labeled HR, Finance, and IT each represent a specific category using binary values. If only the HR column has a value of 1, it represents HR. If only the Finance column has a value of 1, it represents Finance. And if only the IT column has a value of 1, it represents IT. Each of these binary variables is referred to as a dummy variable. However, in regression analysis, it is a common practice to remove one of the dummy variables to prevent multicollinearity, a situation where variables are highly correlated and can cause estimation problems. For example, if we remove the HR column, Finance and IT can still be represented as before. The HR category, which lacks a dedicated column, is instead represented by a row where all remaining columns contain 0. The HR category, which lacks a dedicated column, is instead represented by a row where all remaining columns contain 0. In general, when encoding a categorical variable with n categories, only n-1 dummy variables are necessary for regression models. Including all categories as dummy variables would introduce redundant information, making the dataset inefficient and potentially causing multicollinearity. Therefore, when using categorical variables in regression, one dummy variable is typically omitted, a practice known as dummy variable encoding. Let's go on to label encoding. Label encoding assigns numerical values to categories, making them ordinal. Let's apply label encoding to the employee dataset we used in the previous slide. Here, we assign 0 to HR, 1 to Finance, and 2 to IT. Ordinal encoding is similar to label encoding, but is used for ordered categories. Here, higher values correspond to higher job levels, making this encoding valid. For comparison, let's see pros and cons of each encoding method. An advantage of one-hot encoding is that it is best for nominal variables, as it makes no assumptions about category order. Also, it works well with models that do not assume numerical relationships, like decision trees. A limitation of one-hot encoding is that it can significantly increase the number of features, leading to high-dimensional data. An advantage of label encoding is that it is more memory efficient and keeps the data compact compared to one-hot encoding. A limitation of label encoding is that it introduces an artificial numerical relationship between categories, which can bias models. An advantage of ordinal encoding is that it preserves the order of categories while being memory efficient. A limitation of ordinal encoding is that it should only be used when the order of categories has real significance. Based on the pros and cons of each method, we need to choose the right encoding method. One-hot encoding is best for nominal data, where categories have no order. But it creates separate binary columns for each category, increasing features and memory usage. Label encoding is suitable for large categorical variables. It assigns numerical labels without assuming order and does not increase features. However, it may introduce bias if categories lack a true ranking. We can use label encoding when dealing with many categories, but only if model bias is not a concern. Ordinal encoding is used for ordered data, where categories have a meaningful ranking. It assumes order, keeps the number of features low, and is memory efficient. We can use ordinal encoding when categories have a meaningful order, like job seniority levels. Now, let's implement encoding by Python. First, import libraries. Import pandas for handling a data frame. And import a label encoder and ordinal encoder from sklearn preprocessing to implement label encoding. As examples of encoding, we use this dataset we saw in the previous slides. Using this dataset, we apply min-max scaling and standardization to the column named experience. First, let's apply one-hot encoding. The code applies one-hot encoding to the job level column using pandas getDummies, which converts categorical values into dummy variables. Each unique category in job level is transformed into a new column with values of false or true, indicating the presence or absence of that category in each row. The resulting data frame, df1hot, remains all original columns except job level, which is replaced by its one-hot encoded representation. By default, pandas getDummies converts categorical variables into dummy variables using Boolean values with true and false. In this Boolean format, false corresponds to 0 and true corresponds to 1. If we prefer numeric values instead of booleans, we can specify the data type using the dtype parameter. By setting the argument dtype to int, which means integer, we can change the values in the dummy variables into 0 and 1. In regression analysis, dummy variable encoding is used. In this method, one category is omitted to prevent multicollinearity. In this code, drop first equal true is specified in Ph.D. get dummies, which applies dummy variable encoding instead of full one-hot encoding. This means that one category from job level is dropped. As we can see, the column entry disappeared, and the remaining categories are represented as 0 or 1 in the new dummy variables. Next, let's apply label encoding to the same dataset. We already imported label encoder from sklearn preprocessing. First, create an instance of label encoder, which will be used to transform categorical values into numerical labels. Next, implement a label encoding by applying fit transform to label encoder. Fit transform identifies unique values in the job level column, sorts them alphabetically, and assigns a numerical label to each. The encoded values are stored in a new column called Job Level Encoded in the data frame. The data frame df will now include the original job level column along with job level encoded, where categorical values are converted into numerical labels based on alphabetical order. Label encoder assigns numerical values to categorical variables based on alphabetical order, starting from 0. This can lead to inconsistencies when new categories are added. For example, encoding the job level categories using label encoder would result in disencoded data. However, if a new category executive is added, label encoder reorders the categories alphabetically and reassigns values accordingly. As a result, the encoding for executive is 1, and the mid shifts from 1 to 2, leading to inconsistencies in hierarchical order of job levels. To solve this issue, ordinal encoder enables us to define the order of categories so that we can maintain the hierarchical order of job level. To implement ordinal encoder, first, let's define a custom category order. This line initializes an ordinal encoder and explicitly defines the order of categories. The categories argument takes a list of lists, where each inner list specifies the order in which the category should be assigned numerical values. Here, entry is mapped to 0, executive to 1, mid to 2, and senior to 3. Next, apply ordinal encoding to the job level column. Fit transform is applied to the job level column, transforming each category into its corresponding numerical value based on the predefined order. The encoded values are stored in the new column, job level encoded, within the data frame df. The resulting data frame will include the original job level column and the newly encoded job level encoded column, where categorical values are converted into their respective numerical representations based on the specified order. In summary, one-hot encoding creates binary columns for categories. Label encoding assigns numerical labels, but may introduce unintended relationships. Ordinal encoding is used when categories have a meaningful order. The choice of encoding depends on the dataset and the model requirements. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.